Good morning. In the previous videos, we have seen the how to draw shear force diagram and bending moment diagrams for simply supported beams with UDL as well as point loads. Now, in this class, I am going to discuss the how to draw the shear force diagram and bending moment diagram for beams subjected to couple or moment. Let us see. Consider this example. A beam AB of span 6 meter subjected to a moment, clockwise moment at the point C, which is 2 meter from A. The moment is 24 kilonewton meter. So as always, for simply supported beam, the step 1 is find out reactions RA and RB. So to start with, we don't know. Let us assume the reaction RA is upwards and RB is also upwards. Now, take moment about B. So this RA, when you take moment about B, it goes clockwise. Take moment about B, it is clockwise moment. So RA into this much distance, 6. So RA into 6 clockwise. This external moment, that is also clockwise. So plus 24 is equal to 0. From that we get RA is equal to minus 24 by 6 minus 4. That means the reaction we have assumed RA as upwards, we are getting the result negative. So RA is downwards. So this is the result. RA is downwards. Now, there are no vertical loads given in this question. So RA plus RB, sigma V is equal to 0. RA plus RB should be equal to 0. From that we get RB is equal to minus of RA. So if RA is minus 4, so RB is equal to plus 4. So these are the two reactions. RA is downward and RB is upward. Both are of the same magnitude, 4 kilonewton. So that is the first step. We have got the reactions. Now, coming to the shear force diagram. Once we get the reactions, RA downwards, RB upwards, we have to draw the shear force diagram. What is the sign convention for shear force? If we take a section XS, the force acting left of section upwards, this is positive. So vice versa, right of section downwards is positive. So look into the sign. Consider this point A, shear force at A. It is 4 kilonewton acting downwards. But our sign convention is if it is upward, it is positive. So it is negative. So you draw the baseline. I'll first draw the baseline. So this is the baseline. From the baseline, 4 kilonewton downwards. So it is marked here, 4 kilonewton downwards. Then C, there is no load up to C, there is no load. There is no vertical load up to this. At this, just to the left of B, only load is 4 kilonewton downwards. So it is 4 kilonewton marked here. There is no super go parallel to this. So at this point, up to the left of this, it is downward. So 4 kilonewton downwards. Connect it. So there is no loads in between these two portions. The two reactions are only 4 kilonewton minus 4 kilonewton. Draw a baseline. Mark 4 kilonewton downwards. There is no load. Come here. There is 4 kilonewton upwards. So from here you mark 4 kilonewton upwards. We'll reach the baseline. So this is how we draw the shear force diagram. Now coming to bending moment. We know simply supported beam, moment at support A and B is 0. So moment at A and B are 0. Now coming to this point C. At this point C, there is a load, a moment is acting. So as in the case of shear force diagram, when there is point loads, we consider just to the left and just to the right. Here we have to consider just to the left of this point. Up to left of this point, the moment will be RA into 2 anti-clockwise. So sign convention for bending moment is left of section clockwise is positive. So here the moment is RA into 2 anti-clockwise. So it is negative. What is the value? 4 into 2, 8. So we have right just to the left, RA into 2, it is minus 8 since it is anti-clockwise. Now coming to the next point, just to the right of C, just to the right of C, in addition to this 4 into 2 minus 8, there is a moment of 24. We consider just to the right of it, the moment will be RA into 2 plus 24. So minus 8 plus 24, it is 16 kilonewton meter positive. So you draw a baseline. This is the baseline which you have drawn. 0 at A, MC left minus 8. So at this point, you draw 8 unit downwards connected with a straight line. Just to the right of C, there is 16. So we draw a 16 kilonewton upwards, connect it with a straight line. So we can see the total ordinate here in the bending moment diagram is 16 plus 8, 24. So if there is a moment acting at this point, 24 kilonewton meter, the total ordinate should be 24. Okay, this is how we draw the shear force diagram and bending moment diagram for a beam with moment. I'll pass on to another example. In this case, there is uniformly distributed load and a moment. So just similar to the previous example, always the first step, see, there is 1000 kilonewton per meter for 5 meter, a moment of anti-clockwise moment 15,000 Newton meter acting at 2.5 meter from C. So find the reactions. How will you find the reaction? Take moment about B. Take moment about B. I assume RA and RB upwards. So RA into this distance, 5 plus 5, 10. RA into 10 clockwise moment. This 1000, total load will be 1000 into 5, 5000. That is assumed to be acting at its center. So this distance is 2.5. So 1000 into 5, the load acting at, here it is 2.5. So up to B, the total distance will be 7.5. 2.5 plus this 5. So this produces anti-clockwise moment. Rotate your thumb like this. So this produces an anti-clockwise moment. So 1000 into 5 total load acting at this point. 2.5 plus 5, this is the distance. So anti-clockwise. Then this 1500 Newton meter, that is also anti-clockwise. So minus 1500 is equal to 0. Take moment about B, write sigma m is equal to 0. From that we get RA 5250. So this RA I have marked upwards 5250. Now, next is sigma V is equal to 0. What is sigma V? RA plus RB. I'm erasing this. RA plus RB, upward loads. Downward load, 1000 into 5, downward. That is only vertical load. This is moment, so it should not be considered. All the vertical forces, RA plus RB equal 1000 into 5, we got 5000. Then from that you get RB is equal to 5000 minus 5250, so it's minus 250. So here you get RB negative. So RB is acting downwards 250 and RA is acting upward 5250. So this is the first step. This should be correct. Now coming to shear force, once we get the reactions correct, shear force is nothing but algebraic sum of vertical forces acting on one side of a section. So here consider point A. Shear force at A is 5250 acting up. So if you consider a section just to the left of A, that point 5250, left of section upward positive, so 5250. Now coming to point C, shear force at C, consider left of it, RA 5250 acting upwards, 1000 into 5 acting downwards. So 5250 minus 1000 into 5, 2250. Now coming to this point D, just to the left of it, only this much, 5250 minus this 5000. So just to the left of C, at this point D, there is no point load, there is only moment. So we need not consider right and left, we consider point D. At the point D, algebraic sum of all the forces, 5250 minus 5000, it's also 250. And at point B, coming to point B, the total forces to the left of it, 5250 minus 5000, 250. So we get 250. We got 250. So draw the shear force diagram. How to draw the shear force diagram? You take a baseline, 5250, mark it upwards. Then this point, we got it 250. At FC, it is 250. So mark 250 above the line. Since it is UDL, connect it with a straight line. So this should be a straight line. Okay, now up to this, there is no load. So this 250 extend up to this. At this particular point, there is shear forces B is also 250. So from B, mark 250 upwards, connect it with a straight line. Okay, so if you 5250 upwards, minus 500, you come to 250. There is no load, you go straight, then there is downward 250. From here, you come down 250. This is how the shear force. You start from the baseline, you have to end at the baseline. 5250 upwards, then suddenly decreases to 250. There is no load, it goes straight. There is 250 downwards, you come down. Okay. Now coming to bending moment. In the case of bending moment, moment at A and moment at B are 0. We know it. Now moment at C will be RA into this 5 clockwise minus 1000 into 5 total load acting at 2.5. So what is written there? MC is equal to RA into 5 minus 1000 into 5, the load acting at 2.5. So you get 13750. Now coming to this point D, at this point a moment is acting. So you have to consider just to the left of it and right of it. So just to the left of it, the total moment will be RA into this distance, RA into 7.5 minus this 1000 into 5, this total load acting at 2.5 plus 2.5, 5 meter. So 5250 into 7.5 minus 1000 into 5 acting at a distance of 5 meter. That will get left to the left of it 14375. And when you consider just to the right of it, there will be just to the right of it, there will be another minus 1000, 15,000. So RA into 7.5 minus 5000 into 7.5 minus 15,000. So at the point D, you have to consider just to the left of it. And from this value, you subtract 15,000. So you'll get minus 625. So wherever there is a moment given in the span, at that particular point, you have to consider just to the left and right of it. Now you can draw this MA0. So draw a baseline, MA0. Then at the point C, it is 13750. So at this point C, up to this there is UDL. So at this is point C. At this point C, you have marked 13750. So from A to C, there is UDL. So you connect it with a parabola. So this is a parabola. This is a parabola. Thereafter, at this point C, this is point D. At the point D, there is a moment 14375 just to the left of it, positive value. Just to the right of it, it is minus 625, so negative value. So 14375 upwards, 625 downwards. So connect it with a straight line. So this is straight line. Then from moment is 0, you connect it, see, straight line. You can see this total moment here, 14375 plus 625. This total vertical ordinate is 15,000. This is 15,000. So this is to draw the bending moment diagram in the case of a beam subjected to bending moment. In the case of a beam with bending moment, we have to consider the moment values just to the left as well as right. Thank you. The next video will do the problem of how to draw shear force diagram and bending moment diagram for an overhanging beam. Thank you.